Well, for the first part, we had to get the table outside so we could work on the table. And, well, it's kind of a cool table. It's been around for forever. It's kind of been a piece of junk. So, well, I'm turning it into a useful piece of junk. But it'll be a cool table, it'll have a nice use. So it'll have its own designated use, it'll be perfectly designed for it. Well, we had to cut a space in it for the printer to sit into the table because I wanted it to kind of be inside of it, not on top of the table. I kind of wanted it to have a space or a section of the table kind of like set out for it. And I was like, well, I can just use a router to actually route out a section of the table. So then we had to find the router bits, get a router, and then actually like figure out the spacing, and I did all the measuring and stuff with that based on where the bed was on the 3D printer as I was moving it around. Had a couple of snags because you kind of had to hold it in certain spots when you're cutting out that big of an area. At least I haven't done this enough to know tricks around it, but I realized the more I routed out, the more I kind of had to balance it on one corner because I'd already cut out the rest of it. So you kind of have to play around with trying to make sure it stays mostly level. It took a bit. It was a process for sure. Next step, I wanted to make sure to cut a notch for the wires for the 3D printer so I could have the actual printer piece, like the power supply and the other box underneath it and out of the way, so it's not all on the top, so I can have all the other tools and stuff on the other section of the table. Now I want to actually modify the control box because right now I have a Raspberry Pi, like a little mini computer running the print server for this 3D printer, but I want to try and integrate the power for that into the actual printer power supply so that I can use the power from the printer to power that as well, so I can kind of stack them on top of each other and have it take up a lot less space and only take up one plug instead of two. Once we get this back plate off, this should allow us to get to some of the other stuff inside of it. Kind of release the mess of wires that we've got. So we've got the AC in, and I've got voltage out, and I've got the common wires. So what I want to do is figure out what these voltages are. There we go. 12 volts. Okay, so we might have to get a step-down converter, which we have. So now we're gonna plug it in and turn it on and measure the voltages, play with the adjuster, see what we can do. Be prepared for a loud fan. Okay, we got 12.48, 12.48, 12.48, 12.48. 9 is empty, so we'll use 6 and 9 for our other, to run the Pi. Get a part ready, and then we'll install that guy. Boom. This is a voltage step-down circuit. So right now we're getting 12 volts from our power supply. I need the 12 volts to be at 5.5 volts, and this will take the 12 volt input and down it, and then I'll be able to run the Pi off of the same power supply that this uses, henceforth eliminating another plug. Hey, we're at temp! Now we've got 2 wires that we're gonna solder onto that board. We've got it soldered in, everything, so now that we've got this all taken care of, what we can do is turn it on. We'll use this little dial here to control the voltage. So we'll play around with it, get it to where we want, which we want it at 5.5 volts roughly. So once it's at that, we're pretty much good to go. So you know all those things I told you about that other chip? Well, that's what this chip does. That one boosts it instead of drops it. So yeah, we gotta switch them out because I grabbed the wrong one. So let's get started on that. Alright, let's get some readings. Oh, come on. 5.25. So now we tuck the rest of the wires in here. Our lovely Raspberry Pi. Closed up. Completely assembled test number 1. Go. Got red on lighting the pie.
If a pie could be powered, how much power would a pie power?
Power to power a pie, and enough power to make a pie, man. SD card inserted. Congratulations. Now have information and data collection. That's how you power a pie. I'm gonna fix the drawer on this table because it's been broken for God knows how long. Construction adhesive in various places. Try and get it into any of the spots that we can. I got 2 clicks out of it. Okay, it's pretty bad. It's ready to go. I'm so proud. Oh God. Oh yeah. Success in its finest form. Oh. Action? What's that? I've never seen action before in my life. What are we talking about again? No, seriously, what are we talking about again? We just tested out the machine to make sure it was working, which is awesome. It worked! Spoilers! We were able to get it working, so we kind of hooked it up to the internet because I have it set up as like a box that I can control through a website, so I can control the printer from pretty much anywhere so that I can actually print things while I'm not there, or if I want to monitor a print that I have running, I can do it from pretty much anywhere. So we basically just hooked it up and plugged the Raspberry Pi in to test and make sure that the power was actually enough to run the Pi, which it was, which is good. It means we did it right. So since we were able to get it running, I was able to move around the printer by sending commands through my phone to the Pi and then to the printer. So it was actually really cool to be able to see it actually move around so you could see, okay, yeah, it's actually working. Maybe I cheesed it. No, I didn't cheese it. It was pretty sweet. Yeah, we'll try it when we get everything set up, and it should be a pretty exciting project going forward. So hopefully you guys are excited. No! Oh, come on, man! That's not even fair! Okay, nope. Oh boy! Oh boy, that was perfect! Yes! Oh, that was clean. Totally planned.